Good morning, everyone. I'm Peter Velikin, and I'm with Velobit. We make high-performance SSD caching software, and we're based right out of Boston, Massachusetts. So today I wanted to first chat about the challenges that have slowed SSD adoption and share what our views on SSD caching are. I'll share with you some actual performance numbers that will demonstrate the potential of SSD caching, and then I will talk about our technology vision. So our CTO is a well-known professor and a prolific researcher in the storage area, and when he found that I'm giving this talk, he gave me a whole bag full of papers and patent and research papers and about 85 slides, and he was very, very adamant that I need to cover all slides covering his vision. So thank God he also gave me the cliff notes, so I think I'll try to stick to the shorter version here. Let's give you first a brief overview about Velobit. We were founded in September 2010, and we were founded to commercialize 3 years of research at the University of Rhode Island. We're VC funded. Our investors include Fairhaven, Longworth, and the management team. And we support Linux, Windows, VMware, and Hyper-V. We started shipping on March 28th, and we plan to publicly launch the company on May the 7th. So, Steve, I guess that's another case where you get a sneak preview of a company launch at the IT Technology Day. Since we started shipping, we've had great adoption by customers. You see a chart here with where we have our deployments. We have double-digit deployments on 4 continents, and we've signed up over a dozen VARs. So we're quite excited about the momentum. So what are the challenges that our customers see when they're developing their SSD strategy? Primarily, there are 2. It's the cost of enterprise-grade SSD and the complexity to deploy it. And customers, some customers have very big IT budgets. They can afford to buy the high-end, expensive PCIe SSD cards. Even they are looking for ways to maximize what they get out of them and maximize price performance. And there's a whole set of other customers which simply their IT departments cannot afford to pay the high-end SSD prices. So they're trying to find ways to deploy the commodity SATA SSDs and make them enterprise ready. So that's a huge market as well. Now the other challenge, and that other challenge I find is not very well covered by the media and the analysts, is the complexity to deploy. I have yet to talk to an IT manager who's excited about ripping up their IT infrastructure and reinventing storage protection. That's something that our customers worry about, and they're really looking for ways to simplify adoption and to make it easily to deploy and to scale. Typically, they think of 3 ways to deploy it. One is deploying SSD as a primary target, which gives you great performance, especially if deployed in the server. But it's expensive to get it enterprise ready and to solve the right problem, and it's complex. You have to reinvent data protection. Others are saying, well, I'll just deploy it as a tier. I can get to keep my array. I'll use less. That's expensive too, because now you're beating on the SSD with all the data, and you need to really worry about solving the right problem. And then you have to deploy these complex tiering algorithms about predicting where you move data, and frankly, they just don't work. We're big fans of the third way, which is deploying SSD as a cache. It gives you very high performance, especially if you employ some of the new caching algorithms. It's very inexpensive and very easy to deploy. One of the disadvantages that most of the SSD caches today have is cache coherence, the ability to share data across servers. So what do we think about the future of caching? You know, as early as last year, the summer of last year, we thought that we'll have a really tough job trying to convince customers that they need to deploy SSD as a cache. And the market then just took off by storm. That's no longer the case. Caching does facilitate SSD adoption. It lowers the cost, and it really reduces the complexity of deploying. So it is becoming mainstream. SSD caching now is a hot topic. There's caching on the SSD. There's caching on the server. There's caching in the controller. There will be new caching algorithms which will be optimized for SSD, and there's more coming there. We believe that SSD caching in the future, the SSD caching software, will do much more than just caching. There's the opportunity to optimize data for the SSD, to reduce wear, to improve performance. There's the opportunity to compress data, to reduce costs and improve performance. There's the opportunity to improve replication performance, And there's really the opportunity to stand and be the translation layer to applications. Most applications today are SSD unaware. And it'll take a number of years before they actually start using SSDs in an optimal way. So commands such as trim and other commands. So there's the big opportunity for these technologies to go and optimize data in the foreseeable future. So one other point is that traditional caching is not well suited for SSD. It just doesn't work for flash. Caching has been around for many years, and the most common ways to cache are on temporal locality or spatial locality, which basically means you cache based on the frequency or recency of use of data or its physical location. But flash memory is quite different. It's asymmetric. It doesn't allow in-place writes. You have to worry about wear leveling, garbage collection. You have to worry about write amplification. You have to worry about performance drops as the device approaches full utilization. So the traditional ways, they just don't get the most out of the SSD. If you really wanted to optimize performance and reliability, you need to think of new ways. Our CTO, Qin Yang, invented a new dimension in caching, which he called content locality caching. And it basically explores the similarity of contents in data blocks. So now, in addition to caching based on the frequency and recency of use, you're also caching data blocks based on the popularity of their contents. And that's ideally suited for flash because you structure data in a way that you maximize reads and minimize writes. You are able to optimize garbage collection. And as a result, you get longer endurance for the SSD, you get higher reliability, and you're able to get higher performance. So there's a really big potential for performance improvement when you introduce content locality caching. Let me show you now how we've implemented it. That's an example of how you can implement content locality caching. So Velobit, it's a software that installs on the server in 60 seconds, and it's completely transparent to the application and the storage. It's also hardware agnostic. It works with any block storage. SSD is deployed in a horizontal architecture. This means that only data that's written and cached, only data that's cached on SSD gets written to the SSD, and all the rest of the data goes directly to primary storage, which minimizes SSD wear. We use content locality caching, which maximizes hit rates, and it also reduces the warm-up time of the cache. Also, data that is stored on the SSD is stored in a compressed form. We compress it losslessly at line speed. So what's the net benefit? You're able to pack much more data on the SSD, so the SSD appears bigger than its physical location. So you get more hit rates, higher hit rates, and better performance. And you're also able to optimize data that's stored on SSD. Now, caches are great for random data, but they're not that great for sequential, for streaming data. In fact, hard disks do just fine for streaming data. So we're able to detect data and filter out sequential scans so they get pulled directly from primary storage. We also optimize data that's placed on the SSD, again, to optimize its usage, reduce wear, and prolong the reliability. So let me share with you some performance results, what you can expect if you deploy content locality caching. So the first one is data that uses the data set of the TPCE performance benchmark. So it tries to simulate a real-world online brokerage firm that has real-world compressible data. So we were able to get 14 times improvement over disk by deploying Velobit with a cache that's only 25% of the overall data set. Now, here's another benchmark, TPCC, a well-known benchmark. That, in fact, is probably the worst benchmark you can run with Velobit because it uses synthetic, uncompressible data that's not real-world data. So you're unable to get the benefit of compression that you would get with real data. But even on this data, we are able to get 8.4 times improvement over disk. And again, the cache size is only 25% of the overall data set. Here's another example. So that's actually a customer example. A company called ZoomInfo. They deployed it in a Solar Lucene application, which is basically enterprise search. Now, they could not afford to get a high-end SSD. So instead what they did is they went to Best Buy and bought a commodity SSD, OCZ SSD for $230. They got it from Best Buy, so they deployed it. The SSD, again, is a fraction of the overall data set, and they were able to get 4x increase in performance. So there's really big performance benefits if you start using technologies, caching technologies that are suited for SSD. Next, let me talk about where we see our technology going. Today, Velobit is deployed on the server, and it's a multi-level cache management algorithm which works on all the major operating systems. You're able to get great performance benefits, but in the future what we see is we see a system of redundant caches that are very well suited for virtual and cloud environments. So you have multiple caches in a virtualized environment, and they're able to pass data in a compressed form between the caches. They'll be able to support vMotion, high availability, and so on. And they'll also be able to compress and eliminate redundancy of virtualized data in virtualized machines when it's stored to primary storage. So as a result, you're able to get great performance gains by keeping the SSDs in the servers as you have for performance, but you're also able to reduce the network loads and get great performance in the shared primary storage infrastructure. So that's our vision, and that's where we see the technology going in the future. So that's basically the end of it. Happy to take any questions now or later.